What's up, everybody? My name is Dana Harris with Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I want to show you how to do composition of functions. And so composition functions is slightly different from regular addition and subtraction of functions. We're actually going to put functions within each other. So the first example, as you can say, we're given that f of x is equal to x plus 1 and g of x is equal to 3x. We want to find, we read this f of g of x. It also looks like this. You'll see fog. You'll see something like that. They call it fog. Okay, so f of g of x. What we're actually going to do, we're going to say f of 3x because g of x is 3x. So we're going to take this function f of x, and in place of the x in f of x, we're going to put the 3x from g of x. Okay, so 3x, and then bring down the plus 1. So remember, f of x is x plus 1, but g of x is 3x. So we're going to substitute the function g of x in the x for the function f of x. I hope that makes sense. Now from here, we just simplify. There's no like terms with the x terms. So there's nothing to combine. So we just simplify right there. 3x plus 1. Okay? That's it. Now let's switch it up for the second part. If we want to find g of f of x, we're going to say g, the golf. Okay? That's another way you might see it. Another way it's shown, but we're just basically finding g of x plus 1. Okay, so g of x is 3x, but in place of x, we're going to put x plus 1. All right, and then from there, we just simplify. So 3 times x gives me 3x, and then 3 times 1 gives me 3. So g of f of x is equal to 3x plus 3. Now, in this example, we're going to take two different functions and we're going to find f of g of x. We're going to find g of f of x. Here we have f of x equals x squared and g of x equals x minus 1. So we're going to start off by finding f of g of x. All right, so f of g of x is f of x minus 1. I put x minus 1 here because g of x is x minus 1. So then I'm going to take the function f of x, which is x to the second power, and I'm going to substitute x minus 1 for x. Okay? Now we're simply going to multiply that out. Now this is the same thing as saying x minus 1 times x minus 1. You can use whatever method that you want, FOIL method, double distribution, whatever method you want to multiply these two binomials. I always use FOIL method, so I'm going to do first x times x, outside, so x times negative 1, inside minus x times negative 1, or negative 1 times x, and then negative 1 times negative 1, which is positive 1. We simplify that, x squared minus 2x plus 1. So f of g of x is equal to x squared minus 2x plus 1. Now we're going to switch it up. We're going to find g of f of x. All right. So basically, as you all can see, we're just substituting the one function inside another function. Okay. And we call these composition functions. All right. So now we want to find g of f of x. All right. So that's going to be g of, what is f of x? X squared. So everywhere in the function g of x where we see an x, we're going to put x squared. So boom, x squared minus 1. Now, there's no like terms, so there's nothing to do here. So g of f of x is just x squared minus 1. And that's it. Notice f of g of x and g of f of x are not always the same. Most of the time they won't be the same. Now in this example, we're gonna get down for the get down. We're gonna get down to business. This one is a lot more tedious. It's gonna take a lot more concentration, but same thing. First we find f of g of x. So we're gonna find f of g of x is x plus 5. So everywhere in this function f of x, we're going to put x plus 5. All right, so x plus 5 squared minus 1. Now, there's a couple ways we can do this. Remember, this is the beauty of math. You don't always have to solve every problem the same way. All right, so what I'm going to do first is I'm going to multiply x plus 5 times x plus 5. And I'm going to use some brackets. Okay, so boom, boom, and then I'm going to take that minus 1, right? So this is, I'm sorry, let me take away that squared. So x plus 5 times x plus 5, all right? So keep my negative sign out there, and let's make my brackets a little neater. I don't know why I have to have neat brackets. All right, so x plus 5 times x plus 5 is x squared, because x times x, plus x times 5 is 5x. 5 times x is 5x again, and then 5 times 5 is 25, all right? Then I bring down that minus 1. Now we need to combine like terms, okay? And I don't want to distribute just yet. We still got to distribute that negative sign, all right? So let's keep the negative. Let's get x squared. 5x plus 5x is 10x. And then 25 minus 1 is 24, okay? But we're not done. We have to distribute this negative. So every term inside the parentheses becomes the opposite. It's negated. So this is negative x squared minus 10x minus 24. So f of g of x is negative x squared minus 10x minus 24. Now we're going to find g of f of x. All right. So same process. We're just switching up the functions. I hope this is making sense to you. If it is, and if it's not, do me a favor. Pause and rewind it if it's not making sense, but also share this with a friend, share this with someone else that could use this. And I appreciate all the shares. And make sure you subscribe while you're watching this. So if I find g of f of x, that means I'm finding g of negative x squared minus 1. All right. So I'm going to put negative x squared minus 1 and then plus 5, all right? Got to make sure we substitute properly. So g of x is x plus 5. Well, f of x is negative x squared minus 1. So this one may be a little simpler. The negative x squared doesn't have a like term. So negative 1 plus 5 is 4. So g of f of x equals negative x squared plus 4. All right. And that's that. That is how you do composition of functions. All right. We're just taking one function and substituting it as the value of the other function instead of substituting an actual number. And then after that, you do the operations and you simplify. Young Gurus Math Tutoring. I got the solution to your math problems.